We talked about partial derivatives. Now let's talk about integration. If I have a function of multivariables, say two variables, x and y, and I want to integrate this function with respect to only one of the variables, let's say y. For example, here, I have a function of x and y, so this integrand has two variables. And when I write integral dy, I mean I'm integrating this function with respect to y. So when we do that, what does that mean then? It means I'm gonna hold x as a constant. Okay, like what we did with the partial derivatives. All right, and it's the same that we have indefinite integral and we have definite integral. So indefinite just means we're looking for antiderivative. Definite means we have a lower limit and upper limit for the integral. Okay, so let's then go ahead. Here I am gonna treat 2x squared as a constant and focus on finding antiderivative of y to the -2. So that gives me minus y to the -1, right? And then 2x squared. Okay, make sure we are not taking this as a subtraction. This is a multiplication. Okay, and antiderivative to y is y squared. When we're dealing with antiderivative, in the end, we're gonna always do like plus c, because derivative of any constant will give you 0, so that will disappear. However, here you want to pay attention that because anything that involves a real a constant or something only involving x, in the eyes of y, it's also a constant. So if I have c of x, for example, if I have, let's say, like x squared plus 2, this whole thing in the eyes of y, it's gonna just be a constant. So we can say this is a function of x. If it only involves x, has nothing to do with y, in the eyes of y, this is a constant. So just to keep in mind when we are dealing with indefinite integral, when we write the constant, it's gonna be a function of the variables that you see them as a constant. Okay, so then here, if I write this out, I'm gonna have minus 2x squared over y, because y to the -1 is 1 over y, plus y squared plus any constant of x would be any function of x. Okay, so that's constant to y. So this would be my antiderivative for the function. Okay. Similarly, we have the same integrand, same function inside the integral. This time we have lower limit and upper limit. So I'm supposed to have a constant in the lower limit and constant in the upper limit. But we're talking about constant in the eyes of y. So this can be just like a traditional constant, like 1 or 0 or 2, anything, or it can be something that involves x, so like a function of x. Okay, so that's why I can have like 1, I can have x, okay, or x squared, or any, like for example x plus 2, that's fine. So to y, anything that only involves x is a constant. So the lower limit is a constant, the upper limit is a constant. Then let me take the antiderivative we found here. So 2x squared over y plus y squared. And now I'm gonna evaluate y at the lower limit and y at the upper limit. Okay, so I like to be extra careful just to make sure, instead of writing 1 and instead of writing 1 and x, I'm gonna say y equal to 1 and y equal to x. You can see which variable you're putting in here from the variable you're integrating with respect to. Okay, So the lower bound is when y equal to 1, the upper bound is when y equal to x. You read it this way. Okay, now you know which variable you're gonna plug in. So here minus 2x squared over x plus x squared. So I plug the upper bound into the y minus the lower bound into the y. So that's minus 2x squared plus 1. Okay? X squared plus 2x squared, 3x squared. And then I have this, so that's minus 2x. And I have this, that's minus 1. So this is what I get from this definite integral with respect to y from y equal to 1 to y equal to x. Okay, so if we're gonna do integral, with respect to x, we're gonna follow the same strategy, except this time we're gonna hold y as constant. Okay, so I'm not going to do more example, and you know how to do it. Just like when you do ddx, you treat y as a constant. When you do ddy, you treat x as a constant. And here when you have dx, then you treat, if here you have dx, then you treat the y as a constant, just like that.